Hey gang, welcome to Dr. Frank's Finance World. I am Dr. Frank, the bank. And today, as we said in the last video, we're going to move forward into bonds. Bonds are just another special case of using exactly the time value money, but you're also putting an annuity to it when it's all said and done. But you're getting your $1,000 back at the end. So what it looks like on a timeline is something like this. So at timeline 0, in theory, somebody bought the bond for somewhere near $1,000. That's okay. And you get the payments along the way, the coupon payments, and then somewhere here at the end, you get your $1,000 back. Each of these is divided by 1 plus the I, well, there's not that 1 plus I, which is the yield to maturity. But that's how, this one's divided by 1 plus I, this one's divided by 1 plus I squared, 1 plus I cubed, and so forth. And each of these payments is brought back to today to figure out what the present value or price of the bond is. And just so you know, when you're looking at the N, I, and that kind of stuff, N, in the case of bond, is time to maturity. The I is something called the yield to maturity, what the market wants to earn for it. The present value is the current price. The payment, and we'll see on the next page, is the coupon rate. Every bond has coupons times the face value, and the future value of it is $1,000 when you get your $1,000 back. So that's the basics for a bond. Let's do a problem here. What is the current price? So we're looking for the present value, the price right here, for a $1,000 bond. So we know we're getting $1,000 back at the end. If there are 8 years until maturity, so we know the N is 8, and it pays an 8%, 8% coupon payment, and the market wants 9%. So when we're looking at the 8% coupon payment, it's 0.08 times the $1,000 face value, so therefore it is $80 is what we're going to be getting paid on every single time. So, and then of course we have to come in and figure out what the current price is. So, interestingly, and this is always true on bonds, the end does not change. The end cannot change. It's written into the contract. The coupon payment you're going to get will not change. It's written into the contract for the bond. The future value cannot change. It's written into the contract of the bond. The only thing that can change is the I or the present value. So in this case, your bond is paying 8% and the market wants 9%. So how would you go about getting 9% that you want if it's only going to pay 8% to the end? And the answer is to discount the bond, to pay something less than the $1,000 face value of it. So when we put this in the calculator, we're going to expect a number that is going to be something less than 1,000, so that ultimately our 8% coupon bond with the discounted price will equal 9% between now and when the bond matures. So when we put this in the calculator, we do the favorite thing first, which is to clear the calculator. H is the N, 9% is the I. We know that it's an $80 payment via this calculation right here. So $80 is the payment, and we get $1,000 back at the end. So now all we have to do is compute the current price of the present value, and we can come up with $944.65, and that is indeed the price you would have to pay to get this. Now there is an interesting case when the I for the coupon also equals the coupon rate equals what the market is looking for. And let's put that in the calculator too. So I'm going to clear it and see what it gets us. So if we had an 8-year bond that was looking for 8%, not 9, and it was paying $80, and it's $1,000 face value, you will find that the present value of it, the price of it, is $1,000. So ultimately, when the market is getting exactly what it wants, 8% and 8%, it will sell at that $1,000 price, and it will maintain that all the way until maturity, presuming the market yield doesn't change. But it is a special case when the interest rate the market wants, the yield and maturity, and the coupon rate are the same. It's just a special case. So, case there. So here's another bond problem. You intend to purchase a 10-year $1,000 face value bond that pays interest $60 every 6 months. Now it's getting interesting because we're getting into the other than semi-annual. My bad, that changed there. And the other semi-annual here, let me make sure I mark that up. So the N in this case is, we find out, is 10 years. The I, we find out, is 10% required rate of return. That's right there. It's giving us the payment as semi-annual. So the payment on it is $60 every 6 months. So if this is semi-annual, that has to be semi-annual, and the N has to be semi-annual too. So how do we do that? Well, it's going to pay twice as many payments. It's going to pay it every 6 months, so there's going to be 20 of them. It's going to pay half as much, or the market expects half as much each time, 5%. And ultimately, in the future value of these bonds, you expect that you'll get your $1,000 back at the end. So when we put that in the calculator, here's an interesting case too. The market wants 5%, and your bond is paying $6 or $60 every 6 months. And so ultimately, because the market wants less than your bond, we know for a fact that the present value here, the price of this, is going to be greater than $1,000 because the market is getting more than it expects. It's nice to know what you can expect before you actually pull it up. So we're going to clear the calculator and then clear out our time value money. And the N, as we said, was 20. And the I was half of 10%, which is 5%. And the payments were $60 every 6 months, be 12% a year, but 60 every 6 months. And you have the $1,000 future value you get back. And now when we compute the present value, we get $1,124.62. We know it's going to be more than $1,000, which ultimately means answer A and answer C cannot be the answer. Look for that on tests that you take. That's how I work it in my class. Okay, so moving on to the next problem. We have you just purchased a 15-year bond with an 11% annual coupon. The bond has a face value of $1,000 and a current yield of 10%. Assuming that the yield to maturity is 9.7072% and remains constant out there for the entire life of the bond, what will be the price of the bond 1 year from now? What I'm trying to get at here is get you guys to think about this. The bond matures, let's just say here at time 0. And here we are out here in year 15. 1 year from now, the bond is going to be marching towards its death. On the day a bond is born, most of them are 30-year bonds, they begin marching their way towards their death. I mean, the only difference between a bond and us is we know when a bond's going to end. We don't know when we're going to end. But ultimately, we're getting 1 year closer to our death, just as a bond is. So the interesting thing on this problem is not that it's a 15-year bond, but that you want to know what it's worth 1 year from now. Therefore, the N 1 year from now is going to be 14 years. And 10 years from now is going to be 5 years. So as you're working your way back towards the bond's maturity, keep in mind that the N can get smaller all along. So when we put this in the calculator, I'm going to clear it out here. We are saying that it is a 15-year, but it's 1 year less. So N is actually 14. We see that the I is 9.7072, 9.7072 is the I. We are saying that it is, we're trying to find out what the price of it is. Face value, current 11% annual coupon. So this is 11.11 times 1,000. Put that up here. So that will end up being $110. So we put 110 as our payment, and we get our $1,000 back at the end. So we find out, we're trying to find out what is the price of the bond. The price of the bond 1 year from now will be, compute the present value, $1,096.78, or approximately $1,097. So remember that bonds are ultimately marching towards their demise. And when you have a problem that says so many years in the future, the N has to get smaller. So, all right. And then here's another bond problem. I believe it's the last of them. So Cold Boxes Limited has 100 bonds outstanding and a maturity value of $1,000. The nominal or market required rate of return on these bonds is currently 10%, and interest is paid semi-annually. So let's start to set up the problem. Let's just do it like this. That'll be interesting. So N, I, PV, payment, and future value. I do this every single time. And we find out that the 100 bonds outstanding nominal required rate of return, we find out the I is 10%. It's paid semi-annually, so we have to adjust that. We have to divide it by 2, and it's going to be 5%. The bonds mature in 5 years, so the N is 5, but it's semi-annual, so that's going to be times 2, twice a year, 10. And their current market value is $768. So we know now that's minus 768 because that's what we'd have to pay for it if we bought it right now, is the bond price, and that the future value is $1,000. So the question then becomes, ultimately, what is the payment? When we run this through our calculator, you're going to find something interesting. Also a thing about bonds as well. So I'm going to clear out the calculator. And I have that N is equal to 10, so 10 is the N. And I have that I is equal to 5, so I put in 5 for the I. And I have that the present value is 768 negative. So there I'm using the old plus minus down here. Get that in there as the present value. And $1,000 is the future value. So when I solve for the payment, I get $19.95. But you know what that is? It is a semi-annual payment. You will be getting that twice a year. So when you're converting it back to annual, you'll find out that this is $39.90, or approximately, since you're taking $1,000 times the coupon rate, it's got to be equal to 39, going question mark here, $39.90. You're going to find out that what you're multiplying by here is 0.0399, or approximately, when you go back to the problem, 4%. So when you move into something other than annual, remember to convert it back. The key to this problem is you had to multiply by 2 because the problem that you solved for was semi-annual. And that's an important thing you can miss in the bonds as well. So I'll be moving on to cash flow function next. Thanks for listening. Have a great day. Bye-bye.